Hey folks, welcome back. In this video, I'm going to do a live demo of tuning vLLM today. We'll change some key settings and watch how the dashboard changes in real time, and we'll see how vLLM behaves in different conditions, right? So if you haven't watched my previous video, I'd recommend you go ahead and watch it. It'll kind of explain how vLLM actually works, and then a lot of things that we're going to talk about in this video is going to make sense. Firstly, I'll talk a little bit about my architecture, right? So what I have is, I have a UI pod that serves my vLLM UI. You see this is the application there. And then I have an inference router, which makes a bit of a routing decision. Think of that like a load balancer, but for LLMs, right? So for example, if I have like two different GPU pods, then it will decide that whoever is the least busy gets to serve the request and so on. And then I have my vLLM pod where my model weight is loaded and I'm serving the LLMs directly from there, right? So that's the setup. But in this example, what we're going to do is I will be hitting the vLLM endpoint directly from my laptop. I won't go through UI or through the router because I want to stress test my vLLM, right? So if I send a lot of requests through my router, like the main logic for my router is to make sure that the vLLM pods are not overloaded, and then it can serve quality requests. So it's going to drop or send my traffic. So I'm not going through the router. What I've done is that for this pod, it sits in one node, right? So I've exposed that node port, and then I will be just hitting that node port directly with my request. So to talk a bit about my spec, as you can see here, I have one RTX 3060. It has 12 gigs of VRAM. So this is my GPU. And so a couple of things that I already have would be GPU memory utilization is set to 80%. So out of this 12 gigs, vLLM will claim about 9.6 gigs. Of course, that value can be turned up and down, but that's the optimal way. But again, depends on your use case. But let's just go with that for now. The model that I have is Qwen 2.53 billion. So that's in bfloat 16, meaning that it roughly occupies about 6 gigs. And then 0.5 to 1 gigs will go for CUDA or PyTorch overhead. So from that 9.6, right, this is already gone. These two are constant. So I have around 2.5 to 3 gigs left for my KV cache. So KV cache is that space in VRAM memory where all the token generation and all of those kind of things happen, right? So there will be two things that I will tweak in my setup today. So it's called max number of sequence, right? So initially we'll try when value is set to 8, and then we'll change this to value 32, and we will see what kind of differences will occur, right? So in my dashboard right now, you see that there's this polar health, making sure the router is okay. And then this is just the router logic that if the backend pods are in a healthy state or not. And then how many requests are in queue, and the KV cache, pod count, and so on, right? So we'll see how things respond here. So to test this, I can just go ahead and write something like how many days are in in 5 years, maybe something like that. So from the UI itself, you'll see how long it will take for the request to complete, how many prompt tokens and how many completion tokens, and just kind of adds that up and gives you a total tokens of how much it took. So you can see, took like there's only one part. So usually if I have more parts, it'll tell me which part served that request, but you'll get an overview like this, right? So in this case, 550 tokens were used to complete this request. So, and we should see that reflected here. There you go. So the tokens generated on that part is 658 total, because previously I had like 108 tokens generated, and these kind of metrics fly by. So let's go and let's do some test. Okay, let's put that there, and then so nvrt so this is my GPU node that I was talking about, right? So we see that 9.8 gigs is almost gone out of 12 gigs. That is the vLLM already taking over the memory. So let's clear this. We don't need this guy. And get out from here as well. Okay. So I have this Python load test.py file, right? So all it does is that it has like different ways of running load test. So if I go here, this will be in my GitHub as well. So you can just, clone it from there if you want. So I kind of say my target URL, and then that is the node port IP, and then the node port at which my service is exposed. So I'm bypassing the router, I'm hitting vLLM directly. And then there are different flags on how I want to use this request, right? So by default, I will be sending 40 concurrent requests, times out at 5 minutes, and then the max tokens would be set to 1500, right? So let's let me and then do the vLLM config map. So this is the config map for my vLLM. This is where I define those things like how much GPU, how much VRAM do I want to use, and then what is the number of maximum sequences, right? So what we've said here is 8. It means that at any given time in a vLLM, not more than 8 requests will be handled, right? So this is your GPU, and then you have your VRAM and all of that. So let's say if it can handle more than like your GPU can do a lot of intensive tasks, right? But there are a couple of other dependent things like how much VRAM do you have, how much tokens you can store in your VRAM, the block size, and all of that things. So all we're saying here is that work with just 8 requests at a time. Anything apart from that, they need to wait, right, until a slot is freed up. That's what we're saying essentially here. So now what we will do is, so we've seen that in a config map. Let me run my Python load test. So here I'm saying that run my Python load test with a token of 200 and then short prompts, right? So I don't want more than 200 tokens per prompt, and then my prompts are short. So to see what kind of prompts I have hard-coded my prompts here, right? So short prompts are kind of like what is DNS, what is CI/CD, these kind of things. Medium prompts, as the name implies, a bit larger, and then I have like long prompts, which are like kind of rack style, really big prompts, right? So let's go through the test now, and then let's run the short test. So there we go. So it says that it's going to run 40 requests at a time. Total time would run this test for would be 300 seconds, and then maximum tokens is 200 per output. So as we can see here, we have 39 requests being sent, and then that's the model. So now let's look at our dashboard, right? So this is where we start seeing things change. So see the way I said send 40 requests, right? That's my concurrent request at a time. But since we said that our max number of sequence is going to be 8, 32 of my requests are in queue at the moment, right? So only 8 requests are being served actively by my vLLM, right? By my model, let's say. So you see that KV cache utilization is very low, because we know that this VRAM and this model can handle more than 8 requests, right? That's why that KV cache is really underutilized right now. And then that queue number goes up and down depending on, how busy the queue is and such. So, and like kind of the dashboard repeats a bit of these metrics as well, kind of stores historical data. That's why I have it here. So you can see that, there was 32, and then there's 31, and that's going to go up again if there are more requests in queue. And then you'll see that KV cache is up. So it's 0.68 percentage. And then load score, kind of see how loaded the pod is. So these kind of metrics, right? So that's what we see here. And now it's dropped to 26, and should go back up again. So in the meantime, if I try to run anything from my UI, I'm going to get system busy. All backends are overloaded. This is happening because of my router logic, right? So what I've done, if you haven't watched my previous video, so what I've done is that when our backend is too busy, we don't take any new requests, right? So any new request will be denied. So that's what's happening to me here. It's kind of like, try again, we're very busy. So why are we busy? Because we have that matrix here implemented in a way that if the number of queue goes up by X threshold, we are busy. We're not taking any new requests, right? Because we still have 32 requests to solve. So no point of taking in new requests. And then that's the reason why the UI is going like that. So Yeah, that is one example I wanted to talk about. And of course, this is not an ideal situation, right? So you don't want that many requests on queue while your KV cache utilization is so low. So this is a really bad configuration, I would say. But I just wanted to show this, right? So, and let's talk a little bit about the math, about how many queues will be better here, what is the right number of sequence I need to define, and so on. So let's take the example of what I have. So for this model, assuming first, let's calculate how much memory will be needed for each token, right? So doing that math, it comes out that we need 36 kilobytes per token. So assuming we say that one block will hold 16 tokens, we're looking at 576 kilobytes per block, right? So again, this block size is a value which you can define in your vLLM, but by default it's set to 16. That's just the default setting, right? So one block will consume 570 kilobytes of memory. So we have that. One token is going to cost us 36 kilobytes of memory. So assuming short prompt like this, right, where I ran that max token is going to be 200. Let's say that average request is going to be done with 500 tokens total. That's going to take us 32 blocks for one request, right? We need to give 32 blocks of memory. And then in our case, we have 2.8 gigs given for my KV cache. Say this math here, we came down to 2.5 to 3. So I'm just taking 2.8 for example's sake, divided by 576 kilobytes per block. We come down to 4,800 to 5,000 blocks in average. So assuming we have 4,800 blocks, and then we need 32 blocks for one request. So if I'm running a simple chat workload, I can handle up to 150 requests at a time. So if my model is doing something like this, then I should switch this value to 150 maybe, because that's what I can handle at a time. And now my KV cache utilization is going to go up all the way to 90 to 100%. So it's not going to stay at 0.8 or 0.2. So that's one thing. But right, say if you imagine case B where it's medium prompts, medium generation, right? So one request will take up to 1500 tokens. Doing the same math, 556 kilobyte per block, and that it turns out that we will need 94 blocks of memory for one token. So entire blocks divided by 94, we see that we can handle up to 51 requests at a time. So this is not a GPU limitation, right? This is VRAM limitation. So if my VRAM, say if I'm given here 200 gigs, then boom, that number is just 48,000 to 50,000 blocks. So this is a limitation that is imposed by VRAM rather than the GPU. The GPU can do a lot of things really fast. We know that. It's the VRAM that we're limited to, right? So assuming these kind of workload, that value can set to 51, right? For medium workload, that's fine. But if we have RAG kind of workload, really long prompts, long generation, maybe one request will need 4,000 tokens, which is 250 blocks of memory. So 4,800 by 250, that gives us only 19 requests. So you see how, like, you can't just say that, okay, I'm going to set that value to 20. Right? It's not going to work. It really depends on what kind of workload you serve. So maybe I'm happy with the number 32 because I want to test all of these three examples. Okay, so let's look at this example. So we sent 591 requests. 99% were successful. 6 of them failed. Took 322 seconds. And then a bunch of latency metrics and average token per request. So we see we did define that 200 is the maximum that we want. So 194, and like some requests failed, could be just a disconnect error because I do have a timeout value defined. So that is one example, okay? And we saw that here. So now let's run, let's patch our config map, right? So let's say that instead of doing just 8 requests, we can do a lot of requests at a time, right? Let's patch the config map And then let's say that we change the maximum number of requests to 32. Okay, so let's go ahead and get that done. vLLM. So we see our config map is patched. Now, like me just patching the config map is not going to restart the pod. So the vLLM pod, to get the latest config, we need to restart the pod, right? So you can either do a rollout restart, or you can just scale your replica to, 0 or 1. So I will do that to 0 for the time being. So that's my vLLM pod gone. I'll just confirm that. Get pods. That's vLLM, and then that part is being terminating. So I'll just wait for that to be gone. That part is gone. So let me just bring the replica back to 1. Okay, so we'll just give it some time before the pod goes running. It should go running really quick. It shouldn't take long because the image is already downloaded in the node. So if you put a watch command here at the end, you can always it runs this command every 2 seconds, and you can see what's going on. It says create config error. Okay, never mind. It just probably got the config it needed. So our pod is ready. So let's run the test again then. Let's run a short test. So I can absolutely change my value up and down, but let's just go with the default value, right? So still 40 requests at a time. We'll run this total for 300 seconds. Maximum is 200 tokens. And then after 180 seconds, everything will be timed out, right? So now, if you remember, right, previously we saw there were 32 requests in queue, and then only 8 requests were been actually served by the model. So we'll see that number change now. Okay, so just okay, it's saying it's in an error state. Okay, let's find out why is it actually in an error state. I'll just make sure the pod is up first. Was up, I think it is a running pod. Kubectl logs. Okay, still vLLM cache configuration of an object. Okay, so KV cache took. Okay, it looks like the pod is fine. Now I see this matrix. Okay, yeah, I think it was just taking a while for the applications to be completed. So let's run the short test again. Okay, so we should see things in our dashboard shortly. Okay, there we go. Yeah, so 41 requests sent. Well, 80 requests sent actually. There's 31 waiting, and then 41 being served. So it's not like we're just sending 40 requests, right? We send 40 requests at a time. So, and then we do that recursively. So you see the request number just going up by 40, but then there's, X amount of requests being served and some in queue as well. Okay, so now we see that our KV cache utilization is up. So before, when our max sequence was set at 8, it was less than 1%. Now we are at 3.22%. And then at a time, there's only 2 requests in queue, right? All of the other requests are being served. So we can see that here. So previously, we saw up 31, 32 requests in queue. Now we see that just 2 requests are in queue because our concurrency is at 40, right? So that makes sense. And then we're all the way up to 3.69. That is fine as well. Okay, let me cancel this test, right? Because we did see what we wanted to see here. And then let me run something brutal to the vLLM, right? We'll see if we can increase the KV cache. We'll see how it behaves on a really long kind of test as well. So we'll go long here. And then we'll go that give 1500 tokens. So I just ran a really long test now. So it's 1500 tokens and the prompts are really long as well. We can see that the requests are going through. We'll just wait for a moment before our matrix starts populating. Okay, so there we go. So we see these are really the reason. Maximum number of sequence is still same, like it's 32, right? The only reason the KV cast is going up now is because we're saying that I want 1500 tokens for my output maximum, right? That's the reason KV cache utilization is going up. So and then the queue depth still 40 concurrent requests stays at 8. So the only thing that has changed here is that, like, you know, it's long prompts, it's really long number of tokens, right? So even that is not hitting maximum KV cache. Our queue depth is still at 8. So we don't really see a full utilization of KV cache. So even this is not enough, right? So let me go back to this example again. So if we remember this math, right? I said that if I'm running a medium workload thing, I can go all the way up to 51 requests at a time. That's how much I would have space for. And then if I'm doing something small, then I could have space for at a time maybe 150 requests. For long, I could have up to 19 requests, right? But I think I should have probably just let this guy run, and we'll see that how much token was used in average, and we'll see if that thing actually lasted or not. So the other thing I want to test here would be I want to increase the queue size up to maybe we'll try 150, and we will see if the KV cast shoots up above 50% or not. It should, I think. So while this test is ongoing, let's make our change on the KV cache thing. Sorry, on the maximum number of sequence. So let's set that to 125 maybe. Okay, so that is merged. I'll just wait for this to come. Okay, so that long prompt test is completed, right? So there is a timeout of like, you know, the test would run total for 300 seconds, and then if a request takes more than 180 seconds, then it's going to time out, right? Because some prompts might take minutes and everything, so we don't want to wait too long for that. So essentially the report here is kind of like the maximum KV cast I saw during that stage was like 23%. You might have noticed the polar health goes down and comes back as green sometimes. That is just my inference router. It's nothing to do with vLLM. Because of the latency, like I have a health check for every 5 seconds. If it does not reply successfully to the ping, it marks itself as down. But yeah, it's because of Kubernetes latency. It's like that. I could kind of, you know, make it say every third attempt or so on, but that's not the priority for this video. I just wanted to say if you guys noticed. Okay, so available, so yeah, there we go. So it says that available KV cache memory is 3.21 gigs, right? So we kind of predicted anywhere to between 2.5 to 3, so it's going to use that for KV cache. My application is okay, get requests are going through. Okay, so now let's run the test. So that got updated to 1 as well. See, the KV cache goes up to 14%. It's not really maxing up either. Okay, so the test here is we will be sending 125 requests. It's going to be a medium test, so the max token is going to be 1500. We'll see if the KV cache utilization will shoot up or not. Okay, we see some of the logs here. It says that KV cache has gone all the way up to 49.2. We should see that here. There we go. KV cache at 68.3. Show me that in the dashboard. Okay, so KV cache uses 85.6. Yeah, it's gonna take a while for this to be seen in the dashboard, but we can see it here from the log message, right? Like KV cache jumped all the way from 9 to 85% up to 95%. So there, I think like that is so, yeah. So now it's back here as well. So I would say that is an ideal, that is a good utilization of your GPU, right? Or a full utilization of your KV cache. Let's say like you have not underutilized your memory in this particular situation. That's kind of what my point was. So for me, with my setup, it took me like setting my max sequence to 125, I think that's what I did. config. Yeah, so I set my max sequence to 125, and then I had to send 125 concurrent requests with max 1500 tokens for 300 seconds, and then finally I was able to hit 94-95%. So don't be hitting that high, but I think, you know, like 80-90% of memory utilization is actually good. That way we know that we are fully utilizing our memory, we're utilizing our GPU. So if we actually go to our GPU, we can see probably the temperature is really high and that GPU, yeah, so it's running at 73 degrees Celsius, right? So when you run things this fast and this hot, then you have to take these things into consideration as well. You need to see how much power utilization am I doing. You don't want to go overboard here, and you need to make sure that your fan is running properly. The temperatures are under control. 71%, 73 degrees Celsius is still hot, but it's doable. Like, you know, I think up to 80, like I've seen hardwares go all the way up to 80, 85 degrees. Not the best, but you know, these machines can handle these kind of temperatures. So thank you all for watching.